Hello everyone, welcome to pious-learning, welcome to class 12th. Today we are going to start with the new batch of 2021 and we are going to start with electrostatic first. We'll be posting the 3 videos every week, like Tuesday, Thursdays and Saturdays, and the class will go on like this. You'll everywhere find the recorded videos of us. We'll keep on recording. So welcome to class 12. Without wasting much of the time, let's quickly start with electrostatic first. Okay, so starting with electric charges and field. Let's begin with electric charges and field. You can also find the same content in the previous class video as well, but in this session we'll assure that we'll quickly do the course, and in these 15-20 minutes we'll be able to grasp a lot more about the chapter. So starting with the electrostatic. Electrostatic means electricity at rest. Whenever the charges are at rest, that will be known as electrostatic, charges at rest. Now, what is frictional electricity? What is frictional electricity? I'll be talking about certain terms first before I actually begin with the chapter. So frictional electricity, whenever the electricity or wherever the charges are being transferred from one body to another, when they are rubbed together, that will be known as frictional electricity. For example, if you take a glass rod and you rub it with a silk cloth, then what will happen? Few electrons will basically transfer from one to another. Like in glass rod, say electrons will transfer to the silk cloth, thereby giving the glass rod the positive charge and the silk cloth giving the negative charge. So this type of electricity, which is obtained by rubbing two objects, is known as frictional electricity. You can take the example of silk cloth and glass rod. Okay, when you rub the glass rod with the silk cloth, glass rod will acquire positive charge because it will lose electron, while the silk cloth will acquire negative charge because it will gain electron. You can take some more examples, like you can take the example of fur or a cat skin, and that is rubbed with the ebonite rod. Ebonite rod क्या है? Ebonite rod will acquire negative charge because it will gain electron. And if you rub this with the fur or cat skin, it will acquire positive charge, okay, because it will lose electrons. So whenever two things are being rubbed together, such type of known as frictional electricity. You all know about charges. Quickly, let's talk about charge. Electric charge is represented by Q, and the charge on one electron is 1 E, which is equals to 1.6 into 10 to the power minus 19 coulomb. That is the charge on one electron, which is 1.6 into 10 to the power minus 19 C, where C represents the unit, that is coulomb. Coulomb is the SI unit of charge. Now, charge on any body could be determined in terms of number of electrons that are being transferred from one body to another. We all know that the charges are of two types, positive and the negative charges. For positive charge, substance should lose electron, and for the negative charge, a substance should gain electron. Now, how do you charge a body? So there are two ways to give the charge. First, by friction, and the second one is by induction. So friction, so you know, we just discussed, whenever you rub two bodies and the charge will get transferred from one to another. So that is charging by friction. And in charging by friction, we took the example of the ebonite rod, which will acquire the charge, and the silk cloth. So that was charging by induction. Let's now move to the next one, that is charging by induction. In this case, you induce the charges. Okay, so you are basically inducing the charges without actual transfer of electrons from one to another. In friction, there is an actual transfer of electrons from one body to another, while in charging by induction, there is no actual transfer of electrons from one to another. In this case, it's a temporary electrification of a body by inducing charge by keeping a charged body in vicinity of the another. Let's take the example. Let's consider that you have a conductor which is having positive charge. Now, charges always reside on the surface. Charges always reside on the surface. So, you have a conductor with a positive charge. Charges reside on the surface. ये concept कहाँ से आया? That was electrostatic second. As you go with the subject, you will come to know कि charges हमेशा conductor में बाहर reside करते हैं. Now, you kept another conductor which is uncharged. Okay, so let's keep this uncharged conductor in the vicinity of this conductor A and we mark it as B. Now this is not having any charge. Because of this positive charge, the electrons of the conductor B are pulled towards the side which is nearer to A. So the negative charge will start accumulating on this side and the positive charge will start accumulating on this side. Okay, now by some mean, if you do the earthing of this conductor, what will happen? What is earthing actually? Earthing is connecting a conductor to a earth by keeping one small wire and placing it to the earth. That is an earthing. Now, earth is a conductor with infinite capacity. Okay, earth की जो capacity है वो infinite है. That means that it can give you infinite number of charges and it can also take in infinite number of charges. So this positive charge will go into the earth and your conductor B will acquire negative charge. So this way of charging a conductor is known as charging by induction. In this, you have not transferred any electron from A to B. So this is not charging by friction. Let's take one more example. If you have a conductor, let's mark it as A and you give it a charge positive and in the vicinity of this, you kept two conductors which are in contact with each other now. Okay? They are in contact with each other so that electrons can transfer from one to another. So it is important to keep the two conductors in contact with each other. Okay? We mark it as B and C. Now, when they are kept in vicinity of A, what will happen? The electrons will start pulling towards the closer side and positive charge will start accumulating on the opposite side. What will happen? Now, if you separate these two conductors, one will acquire the negative charge and another will acquire the positive charge. This is once again the method of charging by induction in which there is no physical transfer of electrons from one body to another. It's a temporary electrification by keeping a charged conductor in the vicinity of the other. Let's now do the next one, that is properties of charge. Let's now quickly do properties of charge. Properties of charge. We'll start with the first one. That is addition. Charges are always added up like numbers. है ना? Charges जो हैं, they always add up like a numbers. So if you have a charge of 4e and to the another body you give a charge of minus 3e, the net charge will be left out as e. If a body is having a charge of 4e and you give it a charge of 3e, it will have 7e. So the charges will just get added up with each other with the numbers with proper sign. Okay, so that is the addition property or additive property we can say. Moving to the next one, quantization. Quantization. So what does quantization say? The charge is always quantized. Whenever the charge will transfer from one body to another or a body will acquire a charge, It will always be the integral multiple of electronic charge, है ना. जब भी एक बॉडी से दूसरी बॉडी में चार्ज जाएगा तो इलेक्ट्रॉन की वजह से ट्रांसफर हो रहा है, और इलेक्ट्रॉन हमेशा 2, 3, 4, 5, 7, 8 के नंबर्स में ही ट्रांसफर होंगे. कभी भी 2.5 या 7.8 और 3/4 electron will never be transferred. So the charge that a body will acquire is always quantized. ठीक है. So Q is equals to N into E, where N is integer and E represents the charge of electron or electronic charge. So that is quantization. Moving to the next concept, that is conservation of charge. Conservation of charge. What does conservation of charge says? Charge is always conserved, है ना? It is neither created nor destroyed. It is always being transferred from one body to another. एक body से दूसरी body में transfer कर सकते हैं. This is neither created nor destroyed. ठीक है. ये कभी भी ना तो आप इसको क्रिएट कर पाएंगे ना ही डिस्ट्रॉय कर पाएंगे. इट इज ऑलवेज बीइंग ट्रांसफर्ड फ्रॉम वन बॉडी टू अनदर. एक जगह से दूसरी जगह पे आप इसको सिर्फ ट्रांसफर कर सकते हैं. तो लेट्स नाउ मूव टू कूलम्स लॉ ऑफ इलेक्ट्रोस्टैटिक्स, दैट वी विल डिस्कस इन द नेक्स्ट क्लास. सो लेट्स मीट फॉर द नेक्स्ट क्लास ऑन नेक्स्ट डे. बाय बाय एवरीवन.